First, we have to check if GDAL is installed in our computer. For this, run the command GDAL info. This will list all the parameters for GDAL. This shows that GDAL is present in the computer. Had it not been so, it would have given an error. For example, if we run the command GDAL, we get this error. This is because there is actually no command called GDAL. I'm working on OSGeo Live, which has demo data present in the user folder. Here we'll just copy the demo data to a new folder. As you can see, the new folder named GDAL Natural Earth has been created. This folder contains all the data that was present in the user folder. This is the file that we'll be working upon in this tutorial. We'll now see the working of a popular GDAL function called GDAL info. This gives detailed information about the raster file. As you can see, we are getting this error here. This is because we are not in the directory where the raster file is present. So we'll have to change our directory. Now we'll try running the same command again. This is the detailed output of the GDAL info function. Let us understand what it means. The formats in GDAL are managed by different drivers. Basically, one driver is dedicated to one format. This gives the size in pixels. 10,800 is the height and 5,400 is the width. Coordinate system is also called projection. Some common coordinate systems are SRS, that is Spatial Reference System, and CRS, that is Coordinate Reference System. Coordinates are expressed in longitude and latitude on the WGS 84. This is the projected coordinate of the upper left corner of the image, that is, the upper left corner of the upper left pixel. Here, -180 is a longitude and 90 is a latitude. Pixel size gives the dimension of a pixel in the units of the coordinate system. The first value is the width of the pixel and the second one is the height. The metadata gives some more information about the formats and the data. The corner coordinates are the geospatial coordinates of the four corners of the image and the center pixel. These are expressed in the coordinate system for the first set. The second set gives their equivalents as longitude and latitude. Now we'll discuss another important function called GDAL translate. First, let's look at the formats supported by GDAL. All these formats are supported by GDAL and it can convert files from one format to another. This is the name of the format along with the type of data it can hold. This shows your permissions for the data. For example, you can either read, write, or update the data. We'll now check the working of the GDAL function, GDAL translate. We'll try to convert the .tif file into a .jpeg file. As you can see, a new .jpg file has been created. can get the information for the .gpg file by running the command GDAL info. We'll now get the information for our .tif file. As you can see, the coordinate system for this file is WGS84. Now, using the GDAL warp function, we will reproject the .tif file into a Mercator projection. Here, I have accidentally given the incorrect name for the file. We will check the same function with the correct name of the .tif file. Here, as you can see, the new Mercator.tif file has been created with the Mercator projection. This is how the file looks when you open it in QGIS. This is the older .tif file with the WGS84 projection. You can clearly see the difference between the two files in QGIS. Now, we'll reproject the same file into the ortho projection. As you can see, the new ortho.tif file with the ortho projection has been created. This is how it looks when it opens in QGIS. That's all. Thank you for watching.